Yes? You had your hand up?
I don't think I'll be here either.
Basketball?
No, about it.
Curses. We shall see. Okay, we are now live. Felix, why are you so late?
I was in Mr. Warner's tutorial.
That's no excuse.
Why?
I was
Getting your grade?
no, I was just doing tonight's homework.
Oh.
Let's say that you were studying chemistry.
Crazy excuse.
I was doing my head dentist.
Well, that's good, but you also need to leave on time.
Well, you didn't start teaching.
Yeah, that's not the point.
Kenny, why are you so late? We had
Yeah.
Women's Society.
You'd what?
Women's Society.
See, I'll accept that.
You better have been
Yeah.
chemistry Women's Society.
Yeah. Well, yeah, because one's actually like important for larger society. The other one's important for you. Okay, I think we're in the middle of doing a question last day. If you can have your notes out. We're going to finish off this page first. Felix, go choke. Taylor. Nick.
People are distracting me.
Stop talking then.
They're talking to me.
Stop talking. When someone says stop talking, you don't keep talking about how you're not talking. That's like the opposite of what you should do. KQ trial is also known as Q. This is near the end.
This is PLOS.
This is the last little bit that we need to do, and then we have a practice problem, and then an overall practice problem. KQ trial takes a long time to write, so I tend to write Q, which is an acceptable shorthand for it. We don't want to write K because then we confuse it with KQ trial. If you get a set of values, and this is the problem we were working at last day. We have a set of values, and we don't know whether or not it's at equilibrium. They could be not. So we can shove them into the KQ equation and determine, does it equal it or not? Now, if the KQ trial is less than the KQ, and knowing that the KQ is products over reactants, then which way is it going to shift? At the back. Nope, right here. You're right. I sent you away just to confuse you. Felix? If the KQ trial is too small, so the number is too small, which way does it have to shift to make the number bigger? The products. If the KQ trial is less than the KQ, then by shifting to the products, hold it, is that right? If it shifts to the products, you get less, you get this number bigger, and this number smaller, you'll end up with an overall bigger number. Reactants goes to product.
What is the thing underneath?
Pardon?
Like the hashtag over what?
That's the number
Hashtag
is
over
bigger,
hashtag.
over number is smaller. He's just like graphically.
I just graphically made the number bigger.
Okay.
So the KQ trial, if Q is too small, then it must shift to the products to make Q bigger. And K is the products over the reactants, so we shift to different sides, the overall size of the number shifts. Now, if KQ is a small number and the KQ trial, or Q, is a very, very large number, which way will it shift? Reactants. So this is how you can prove mathematically which way it's supposed to shift. So if KQ is too big, and this sentence is written completely incorrectly. What's going on here? if KQ is too small, then must shift to products. If KQ is too big, then must shift to reactants. To make Q smaller. To make Q small. Now, what if the KQ trial equals the KQ?
Then the equilibrium is
Which way does it shift though?
It just stays.
stays the same.
Stays same.
Shifts to none or something?
Ooh, I like that. Shifts to none.
Nowhere.
Oh yeah. Extra.
Shifts to nowhere. Like the bridge to nowhere. Like the bridge to nowhere in Alaska, I think it is. Bridge to nowhere in Alaska. It's a famous bridge in Alaska. Part of being a state or a province is getting funding from the federal government. So there's a big push in the US a number of years ago to improve infrastructure. And so Alaska applied to get a big bridge put in because it means a lot of money and resources and employment. And the bridge literally doesn't go anywhere. They just put in a bridge. It became a sign of government waste. It was, the person who was in charge at the time was Palin, became famous because she was also the running mate for John McCain in an election way back when. This is probably all before you were born, never mind. So if Q is 2 equal, it's 2 equal. It must shift to nowhere. Actually, technically, it's still going both ways. So you could say it's shifting to everywhere, which ultimately means it's not shifting. To make Q stay. Good boy. It's not shifting, it's not going anywhere.
It's going everywhere.
But nowhere.
Like everywhere but nowhere. at the
Everywhere
same
but
time.
nowhere. It's like running around the room. but not
Everything
leaving.
everywhere all at once.
Everything everywhere all at once. Ooh.
What a
So,
cookie.
now we'll finish off that question. And you can turn back to it if you'd like and start it. However, I'm going to put you into groups as soon as I 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Who's missing? Who? Milan? Stop that! Who else is missing?
Sonia.
Stop that. Okay, Anae, Dylan is here. Eric,
Everyone's here, yeah.
Eshwan, Felix, Enora, James, Chloe, Luca, Luce? Luce is missing. How dare you forget about a student in this class?
How did you forget? Because you had known all along. You would know.
That's true. That's true. I think I should share with you the existential teacher talk.
Doorward.
Dorward?
That's his last name, right?
He's here.
No, someone just said that. I thought you were asking a question. Okay. Find your partner and do that problem on the board. Eric, you can join anybody you like. Go, 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 go. Anybody still need this up? And the problem that we're doing is That one.
All the pens are back.
The box of pens someone brought to the back. If you have a bad pen, throw it away. Get rid of bad pens.
Look here.
Or like
That's a bad pen?
Hey, we did this one, didn't we?
Felix,
I just
problem.
said it.
Working on the problem. Echelon, stop looking into your partner's eyes.
Second I walked, I was like, oh. Don't we have to use ice tables?
You're doing that problem.
You don't look like yourself.
No, we're doing this problem. This.
You know what I
Oh, can I have that green pen?
How I looked last year?
Oh, that green pen is so cool. So cool.
Oh, it's
I
right.
existed.
Stupid green pens. They really stain the board so they don't show up well. No, don't wipe with your hands. Just start writing over it. Is the black pen good?
No.
Excellent. Better.
Wait, are we doing?
No, we're doing the, yeah, we're doing this question.
Oh, I thought we
F8.
were doing this one.
No, this
Oh,
one.
wait, we're doing the other one. That's the one.
Yeah.
We take one off my desk.
I don't know if they use that one.
Oh, 8 here, we're doing this.
These are all gas, right?
You need an ice table, right? Oh wait, no you don't.
Like once I have a calculator, I always
mold.
That's like really true. Yeah, but what do I do? But like, this is like, see my x. I know my x squared is your x cubed.
You don't need an ice table.
Yours are in different spots.
Luca, you don't need an ice table, right? They already have one.
Oh, you know, like it.
Wait, is that from equal to Sam? Or is that the original concentration?
So nitrogen monoxide reactor. Oh, you just answer it. I know what you know.
Oh. It was a nice table though, like it was like a node 2. Mr. Neufeld?
And there was 1 molar?
One?
Yeah. Or no, just
What is? Oh, sorry. Where did you learn that? What is common? Instead of decimal.
That's Europe.
Yeah. That's what, where in Europe?
instructional system.
Pardon? Oh,
They're
yeah.
all of Europe.
Well, it depends how much Germanic influence they have.
Why is that only a German thing?
It's a very much a German thing. Yeah. And Switzerland is definitely influenced by Germany.
Oh, yeah.
Yeah. Cool. Okay. I just confused you. Looks good. Well, shit's product makes sense. Yeah. You got the whole equation? Yeah, you can. You can just start working on this.
Actually, yeah, you do. Actually.
Oh, it's like you have.
No, and you can just put you in different groups for next week.
Yeah,
Just
because
start.
we like Austin.
Wait, they didn't give us 49. Oh, it's 49. This question is weird.
I don't know what it's asking.
Martin, how you doing?
I don't know.
Yeah. What have you been doing to catch up?
I've been doing my half marathon, but like almost caught up.
Okay, do you know what a KQ equation is? Okay, so, not cut up. So KQ equation is products over reactants.
I was like this.
So I'll start off with that.
Yeah. And I can.
So one of the first things we did,
So you have it set up.
in fact, they don't need to look at this, so just come over here. Let's go all the way back.
You went on a calculator.
We introduced the equilibrium constant. And one of the first things we did was that if it's at equilibrium, none of the concentrations change. You can develop a constant from it that if you take the concentration of products over reactants,
No, I just.
so you take the products
You don't need to write
and
them.
put them in,
I'm going to write the whole
Okay,
thing.
right.
and then take them to the power of their coefficient, and you make a little number out of that, that number will always stay the same for that reaction at that temperature. Change temperature is the same. But it doesn't matter what concentration was there, they will always eventually end up in that ratio. So it's products or reactants to the power of their coefficient. And then we just practice a few times here, making these equations. The little snafu there is that you remove the solids. And it turns out, pure solids don't change concentration. Liquids also don't change concentration. Are there any liquids in this one? No. But you would also remove any liquid. So we just put these, remove the solid, so there's no solid, there's no product, there's just one over. Just becomes pure.
All gases.
These are the rules for it. Pure liquids are omitted. If the liquids can mix with each other, there's a chance that they could be in there because now they're changing concentration. But 99% of the time, they're not changing concentration of pure liquids. They're there. So we didn't practice with those right KQ equations. KQ equals what concentrations over there. Once you have that, what does it mean? It's products over reactants. So if you have a really tiny one, that means you have a big number on the bottom and a small number on the top. So that means you have lots of reactants. If you have a large tank, that means you have a big number on the top and a small number on the
As soon
bottom.
as I turn 30, that's it for me.
So we look at what is the number.
No.
And then we just solve for it because they're actually concentrations. We can skip that for now,
It's not very hard to like.
which is write that with the KQ, throw in the numbers, and you can calculate with the KQ. So for that one it's 11, so there's 11 times more products than there is reactants. So you can start using KQ to calculate the they give it to you in the question. So they give you the concentrations, or in some cases, we'll see what they do it on the next one. They give you the moles, but then they give you the volume. So you divide by whatever.
Why do they make me?
And then we introduce ice tables.
This makes
You
sense.
need to solve.
Look at my.
Do we have this anymore? No, apparently it's not working. Oh.
Yeah. I better not look like this one.
Did you hear something?
Yeah, because it's like the tester where
Oh, yeah, good. So ice tables, initial change concentration. So before we were getting concentrations, it was just like this is at equilibrium. Now you get questions where you say, oh, here are your values. We just put it in. It's not at equilibrium. You know it's going to shift because there's nothing on that side. So it gave you one of the values in this question that was at equilibrium. So you can figure out how it shifts. And then which way it moves depends on the stoichiometry. So this divided by 3 multiplied by 1 gives us that. This divided by 3 multiplied by 2 gives us that. So the change just uses the old stoichiometry from term 11. And everything else is figured out. This minus that gives us that. This minus that gives us that. That plus that gives us that. And then we have all our equilibrium values. And we can go back to calculating.
I better not look like that when I'm old. I'm gonna cry.
What you get on your
Sophia, why do you?
Now I'm not expecting you to remember all this. You're just gonna go through and practice some of
No,
these
good, you
and
look
hit some
good.
practice problems. And then we introduce the
You know.
idea of
Look how
excellence.
good
We
Sophia
give you
looks.
all the initials.
She looks
You-
amazing.
extending high.
In this particular case, you know the KQ.
I'm confident that I got it.
Echelon.
What did you get?
You know the KQ, but now we need the concentration values. Since we know it goes with coefficients, we can say, well, this side is going to drop in value by the same ratio, and that's going to increase the double because of 1, 1, 2.
We're gonna.
And then we can just put that in the KQ equation and solve for x.
Look at this. This is be an
When you
echelon.
start doing that, the important thing to realize is you never have to solve for quadratic. They'll always end up, if you take the square root of both sides, you end up solving just for x, not never x squared. We're not a math class, and regular old-fashioned chemistry 12 doesn't make you solve
Why
for
do you
quadratic.
look so good? It's
And
so
then now we're up to today, the idea that we don't know if these are at equilibrium or not, so we calculate them as if they are, and then compare them to the KQ and see, well, is it at equilibrium or is it not? So if I was to write this as a KQ equation, what would I
Why
write?
do I look like my throat? You look like a turkey square.
Wait, just wait now. Go like this.
Not plus times. So they're always times.
That's like auto.
Yeah. And then you plot those values in so you okay? So yeah, practicing when you can. Also, we have a standing appointment every Tuesday and Thursday.
Yeah, one of those freaking.
So whenever you're ready, we can get back into it. Okay?
She looks the same almost like you.
Yeah, we'll watch it. Okay. Sorry? Just now, how many people Dylan, phone please.
Yeah.
You're not working on the next question?
Oh no, I we were turning each other like into old people.
If as I look around the room, that is true, but you want to state if it's bigger or smaller. So I do want to see eventually the actual number. Did anybody get 4? Like just 4?
We got 0.4.
0.4 is the correct answer, so you got that's good. The last class, about a third of the people got 4. It was one particular mathematical mistake, and I thought it was going to be common this time, and it's not. So you're doing really well. Well done. Everybody has a sentence down, and that is good. Nobody skipped writing the you skipped writing the KQ equation. You would still probably, if you got the right answer, you'd probably still get full marks for it. But let's say you're doing this, and you jumped straight to
That was weird.
0.2 molar squared over 1.0 squared times, is it 0.2? What's this number here? 0.1 there. Let's say you skipped writing that and you just went straight to here. I can see that you know it. If you get the right answer, I may be tempted to be like, well, they know it. That's what it. But this is an entirely separate piece of knowledge that you then put stuff into. So if I'm trying to evaluate, do you know this, and you skip that step, and then you get that step wrong, then it's really hard for me to give part marks. So if you put that in and it's correct, then I can give you part marks for that, and you do it wrong. If you put that in and it's incorrect, but then you put the numbers in correctly, you do everything else correctly since then I can give you part marks for that because I can see the type of mistake you made. If I can't see the mistake you made because you omitted the step, it's really hard for me to judge your proficiency. And so a lot of the showing of work is just so that we can check. And that's not just this class. That is anytime you're going to be showing your work to anybody, whether it is in an industry or in school, or because you're running a business, you're going to have to prove it to somebody. Okay, and then we end up with 0.4. 0.4 is smaller. What did we have? 49. Therefore, reaction will shift to products. Okay. I'm going to give you groups to do that one. What'd you say, Dylan?
This is so hard. I don't know.
What?
Is this the hardest unit we're going to do? Is absence and basis hard?
It doesn't get any harder than this.
Okay.
Until we do more.
Yeah, I think he's lying to me.
Do you remember doing stoichiometry in grade 11?
Yeah, that was like.
Is this harder or easier than that?
Harder.
I think
No,
it's
easier.
I think it's easier because we already know how to do it.
You already know how to do it. So as time goes on, it's not that there are things that are harder. It's that you'll know this better and it will become easier.
Okay.
Right?
Yeah.
So,
It'll get harder.
This is the hardest to open.
yeah, I find the calculations of this actually easier than Chem 11 stoichiometry. It's new to you. But in terms of the amount of Chemistry 11 can literally ask you so many things. Molar volume of a gas, what are the grams, what is the volume? Like you can branch off, and the word problems are much harder in Chem 11. Whereas this one, it's like if you recognize you need an ice table, it's that type of question. If you recognize you need to just calculate the KQ. It's that there's like much more limited amounts of questions that
It's
it
like
does.
2 ways to go, basically.
Yeah. But they both use the same type of math.
Yeah.
You don't have to solve for a quadratic. It's all going to be algebra. We will do logarithms. How many of you done logarithms already in pre-calculus?
Well, I mean,
You've done. If you haven't done them, don't worry. I teach it to you, and then it's the easiest thing in the world. Okay, get in your groups and do the next problem.
Why do that with logarithms?
Let's make Taylor.
Teddy, I'm going to say follow Martin around because your job is also going to be to help catch him up.
which question are you?
Martin, are you still ill? Okay. You don't need a master. Okay.
Mr. Newfeld, what's question are we doing?
Oh, the one that's on the board. Everybody have their
Yeah.
Teddy. Teddy. No. I said follow Martin around because he actually needs catching up. It's in the questions in your
I don't think
sheets.
we're doing that one.
It's this question.
Yeah.
I will say there's two ways of solving this: the rough and ready and the elegant way. They both worth the same amount. One's not extending or extending high. But if you can solve it the elegant way, I will be impressed.
Hi, Dad. Yeah, you were right, Eric. Okay, so yeah, we didn't KQ at this temperature.
Oh, we also we're not there with that question. Okay. We're doing this. Oh, okay.
We don't know. So everything is 0.
Okay, we have to
What?
Like in the ice table.
Science 10. Sorry, what?
Like in the ice table, everything is technically 0 because we don't know how much we start with.
What's the question?
I feel really stupid.
Is it solved for what it is at equilibrium?
Well, we have to find the polarity, right?
No, prove with calculation which way the equilibrium is going to shift. You need to know the KQ. KQ at this temperature is 7.0.
No, Q is like Q like the trial. Like
Equal moles of everything are added.
And then after you if they're equal to each other, so that's not good. If they're KQ equals like what you text,
All concentrations are
So whatever side's more, it's more than that.
order 1,
Where's my?
the moles are all the same echelon and the medium is the same.
There's just one, so one over
Oh yeah, I see what you're saying.
one, and then I have a big multiple run, and there's all seven.
Yeah, that makes sense. Okay, it makes sense.
If we want full marks though, we have to put in 1 for everything, or
How does the KQ equal 1? You did
It's
prove it.
7. I thought it was a 1 or 2, but it's a 7.
It is 7.
so 1.
But how did you calculate KQ
It's all
equals
the
1?
same moles and same. Mole is.
Because any number.
And it says
You
that's 7.
need to show prove via calculation.
Go Dylan.
Prove.
We have to put
So
in
we
every
just have to
possible
prove
number.
that if the numbers
No, but there's something mathematically you can do that is every possible number.
What?
Also, that's not KQ.
How
That's
can you
a Q.
represent every number, like infinity?
KQ trial.
Are you saying like infinity? Like,
Infinity's not a real number.
Any number over any number is 1.
so like x?
Felix, would you give me your-
Oh, you're doing x.
Go.
You have to do x.
Dan, no, this is not a sit down and
I taught him
relax.
though.
We
I'm
don't.
actually so
You guys ain't done.
Well, I have to show that 1 divided by 1 is 1.
You haven't shown anything. You showed a formula and then magic happened and you went KQ equals
1
1.
divided by
Mr.
1.
Then show it.
Mr. Newfeld, is this enough
Therefore,
to say like
Equal moles over all concentrations are equal to what?
to each other? They're the same number.
Maybe write that down.
just do dot.
Mr. Newfeld.
Yeah, if they're all equal to each other, what could you substitute?
If
You can pick a number or X.
shifts to product.
But why wouldn't it like
So you want us to do like x over x times x?
Equal moles over all concentrations are, oh! See, when you use an equal sign, what you're saying is all concentrations are equal, and then it's like,
no, they're
to
equal.
what? Yeah, write it. Right. Don't confuse the words. Well, you're solving for a cat. Stop solving for a cat. Yeah, I'm not. I'm not gonna mark solving for that.
What?
This is scary.
The battle.
That doesn't feel like you learn.
This is
Which one's yours?
how we
Oh,
solve
that's
it.
beautiful. Yeah.
Bro, I watched like
guys solve it
YouTube
for a
and
quadratic?
they use quadratic.
Yeah. Go to AT.
Oh, yeah.
equals a bunch of things, and then you just said 7 doesn't equal 1, which is a random
Oh, I
thing.
think it's like this.
You know what else doesn't equal 1? Everything but 1. Yeah, they put in a lot of units. I don't know what that represents.
That's not good enough proof, big dog. That's not good enough proof.
I know what concentration is, yeah.
Okay, well, what?
Put in x value.
Okay.
It can be any value, and all of the x's cancel.
I don't know what it
Or you
is.
could just write all
Why are
concentration.
you
Oh wait,
saying math?
Yeah, but you have to mathematically.
But I don't care about
That's
that.
not
I care about,
he said it was.
Oh.
Oh wait,
Oh, that
when you
works.
say all
yeah,
concentration.
yeah, that's, so you've proved that the units will cancel out. You have not proved what the number is. Okay, we do that. Oh, I just said 1 squared over r. 1 squared, so you substituted 1. Why didn't you do that in the equation? You have written 1 nowhere else at the very end.
No way, you just said we ate
I,
that.
I'm judging work, and you simplify too much, then you have shown no work.
She didn't eat it.
Simplify
Just
after
ate
you
it.
show. Show first. Yeah.
It makes
Yeah.
sense
No, now fix board. Felix, go help him.
Do you want to just take the square root of everything? Just get rid of it?
It's not like a.
Otherwise, I don't get it.
Hmm.
Guess it's not fixed like
Yeah, I think you might have done something incorrectly. Yep.
Sorry.
Oh, I'm not, we're not on this question.
That's really out of pocket for me.
Was it though?
Top always equals bottom. Yeah, you've explained something, so that'll work. Yeah, that's good.
I told you that's not how it worked. I didn't do it.
Okay, a couple of pieces about this one, if I can get your attention. Because I was deliberately being irritable, well, irritating probably, and obtuse. Because if you're asked to prove something, that is much more thorough than just showing the answer.
Mr. Newcomb.
Everybody had the KQ.
Mr. Newcomb.
Yep.
When we like to decipher if we need an ice table or not, do we just need it when it doesn't give us like the KQ and it doesn't give us like it just gives us like initial and like.
If you don't have equilibrium values, you're going to need an ice table.
Okay, and
If
then
you-
it'll kind
if
of
you-
say in the question.
pardon?
It'll say like kind of in the question.
The question will tell you if they're equilibrium values or not.
Okay.
Is that the question? Yes. And then looks like everybody successfully wrote the KQ equation. But then, where everybody then had that glimpse, that moment of aha, and they went 1 is less than 7. But that doesn't tell me anything. That only tells me something if I already know the answer. And if someone is checking your work and they don't know the answer, you didn't prove anything. You wrote an equation, and then you wrote an entirely true statement. This could also say 17 does not equal 12, and deer are not dogs. These are just true statements you're writing,
17
apparently at
dogs.
random. Because what connects this to that?
17 equals 12. Not a true statement.
Taylor, Eric, please put those down. We are working on the old question, not the new question.
But like.
Nope. Taylor? Thank you. You need to connect these things. If you make a statement, it must easily follow from the first one. Now, knowing that they're all the same, you can at one point just say that the concentration of CO2 equals the concentration of H2 equals the concentration of CO equals the concentration of H2O. And then you could say let the concentration of CO2 equals 1.0 moles per liter. And you're just going to solve it using actual numbers. And then you put the numbers in and you get 1 times 1 over 1, which equals 1. And now you've justified 1 is less than 7 because you showed me how you got the 1. You took it from your brain, what you did, and you put it on there, and now we can see the why you think that. Also, 1 is a terrible number to use if you're ever doing this, because there are chances What if you pick 7? There are versions, this one will work for this in almost every case. Doesn't even matter if this is squared and cubed. 1, 1, 1, 1, 1 will still equal 1. And for almost every KQ that has a top and a bottom, 1 will always work like that. So this is also a terrible number. If you're going to use the number method of solving, then you might want to check it with different numbers. So instead of 1.0, if we meant 7, that's not going to always be the same, and that would still cancel out. And so you end up being okay, and you can see that it works.
Why?
I don't even know what's happening right now.
Why did you? Okay, 2 questions. Why did you have squares on the ones?
I was just showing that if this was a different equation,
Okay.
it would still work for 1, but no other number.
And could you write just like x and x and x?
Yes. Now the elegant way of solving this is say, let's make it, what do we do with numbers in algebra when we don't know what the number is?
Give it a variable.
We just like, we say, oh, well, that's x. And then instead of this, you'd have x times x over x times x, and then you get x squared over x squared, and then you know that equals 1. And you've now done an infinite number of numbers.
Yay.
You've done every possibility. And then you can finish off with the 1 is less than 7, therefore the reaction shifts. Which direction?
Products.
Products.
And then if the one that was like 17, would it shift to the reaction?
Yes. Yeah. Okay, the last question is just a review of ice tables.
Ice, baby.
You right, Felix.
Oh my God, Mark.
Oh,
Dylan? Follow Martin Berry around. Teach him everything he hasn't learned.
Don't do that.
wait.
Yeah, follow him around.
He doesn't want to. He doesn't want to.
That doesn't matter.
Oh,
Teach him everything. Find your group. Last question.
Teddy's my roommate. He's good. It's good. Perfect.
No, you now have Dylan.
Me and Myron.
Martin, you're with Teddy.
Martin, how are you feeling?
And last time Teddy followed you. Weird.
like that.
You really by yourself? Yeah.
Somebody's trying to force me to get part of it.
Huh? No.
I hope I had it.
How'd you get this many markers?
I went and bought them. I bought 36. 36 markers. Did I show everybody my Kleenexes last day?
No.
Oh.
Wait, let me get spray.
No, I'm kidding.
Also, just so you're aware, if you have a cold and you need a Kleenex, I bought 2 last day, and then I found out somebody in another class, some teacher came and stole them for their class.
Probably just like acid. She has like 5.
So you know what I did? If there's people with colds that need them, I have now over a dozen.
Wait.
She's like 1
Yeah, because that's what they do.
That's a Kleenex.
Well, no, I think it's probably something way over. I always just blame any nearest physics teacher because they're so jealous of chemistry.
Perfectionists.
Oh, you are on this last question. Dylan?
Yeah.
Why are you over there?
They're teaching me really well.
Okay.
obey your commands.
Dylan didn't. Maybe I should take away his spare.
I don't have a spare.
What? Really? An
There's
empty
no
set.
spare to take away.
Martin?
I'm a busy man.
Write down the KQ equation, like the formula,
In this equation?
so that you can do that.
Wait, Mr. Rudolph,
Yeah?
what do they do to you when they take away your spare? Like,
You sign the library, or have you ever, say, a prefect
yeah.
who skips a class a couple of times?
All the time.
Let's say a couple of times.
Dylan, I think you know about stuff.
then
Right?
you will accompany me to my class
Eric, you're wrong.
during your next morning spare.
That'd be terrible. That's so embarrassing. You have to sit there all.
Not in the class. I just put them over there.
Oh,
Yeah.
Mr. Neufeld, the negative X stuff. Yeah.
That's initial.
Sorry? Nope. You can't ignore it at all.
Why would it be positive and negative?
Which way is it shifting?
Well, I don't, so container, the KQ is 7, how do I know what side? It could just be 0.
Yeah, which way is it shifting? Look at your initial values. There's only one way it can shift.
Oh, to the shot.
Also, you have missed something fundamentally important about your chemical equation.
About our chemical equation.
Yeah, and it's affecting all your later results.
And then how do you
That makes sense.
Whoa, what's that on the bottom there?
150.
I don't know. You have to do something with it, but I don't know what.
These are, which way is it shifting? Look at your initial, no, initial values, there's only one way it can shift. Right, so would you, are those positive or negative?
Told you.
And then what signs goes in front of those? Those other X's? Yes? And then when you get below that, how do you get your equilibrium value?
Oh, yeah, true.
What? How did you get an actual number? Stop doing that. No, equilibrium value comes from X. 0x?
Oh.
One,
And also.
there you go. And then what about that other one? There, now you're set up to do an equation. Write the KQ equation with all the concentrations so you plug them into the right spot. Make sure you write an actual KQ equation with all the concentrations so I can see. Good, excellent. Finish that
What
off.
do I do now?
The ice table.
I forgot how.
Which way is it going to shift?
Well, it's obviously gonna shift to the
And then this whole thing is just gonna equal.
I don't know what that is.
products.
Why?
Because I mean it has to get to 7.
Why would you say obviously?
Because it's 0 over.
It's nothing right now.
It's nothing.
Right, because you haven't calculated any equilibrium values. And you know it has to get to 7.
How do I calculate it?
But just looking at your numbers, which way doesn't have to shift.
To the product.
Right. So what things go down below?
Mr. Neufeld, can you look at this?
1 second. Let's go all the way back.
This is where we made this negative 2x.
What do we do? What do we do when we don't have those values?
X. Oh wait. No.
That's a different question.
What do you think we did wrong here? I think we factored this.
Yeah, that's you have oh yeah, you did, yeah. How did you go from x squared down to x?
Oh wait, I know how to write it.
Oh, I factored out maybe
Backwards?
yeah, out the X.
No. This is the mysterious text. How did you go here?
Because you have 0.
Only out of the products, so this side is more.
And when you do something, you should indicate it. Like up here. You say, oh, here's the experiment. Do that. Excellent.
How does negative?
Going X, Y is a standard
How
form.
did you go to this?
I don't know.
This.
No, it's just crazy.
distance. Where's your KQ? Oh, excellent. So if you go from there to there, you put X in there, right? Or what you put there.
Oh, I don't know if I read it out then.
There's something
What did I
missing.
do?
Wait, no, we would have to wait. So we want to take away. Wait, no.
It's squared, so that also must be squared.
Oh, if that's
You
square,
can,
then
you
it's
can,
square
you can
root
shove
equals
like
up.
shove this. I mean, they're on wheels. There you go. You got more room.
7 times 2x. Multiply that one.
Take,
So 0.75 times 2x times 7.
take everything.
Wait, we're not supposed to use the quadratic formula in
Put
this
it
class.
directly in there.
Yeah, we did
I
nine
don't
plus.
see
Oh.
there.
And then we squared it.
Yeah, do that.
Teddy,
Do that at the
you're
bottom.
going crazy, man.
Is that good?
I'm already crazy. Crazy? I was crazy once.
Yeah. Now, what did you, no, hold it. What did you do to go from here to there?
Okay. Felix, it still wouldn't be 14.
Oh, you can't do
the
that.
7.
Oh yeah, you can do that.
You got rid of
What do you mean?
There's a.
Why are we in the
Wow.
quadratic
You
formula?
can't, you're not just
Yeah.
Big
cancel.
dog. Big dog is
Yeah, they have to be identical to cancel.
Yeah.
Wait, that doesn't make, isn't it?
Mr. Neufeld, will you go over this question?
Oh, so that would do
Yeah.
something like this.
There you go.
This,
I
this,
I
This
think
is before your 7 was in square root.
Nancy got it.
and then
I don't,
It's like going off right now.
where do you go from here? So that,
see if I could just.
Excellent.
What's the answer?
Oh, you didn't put it in here.
Yeah, because what else?
Yeah, and you put it into this, right?
But we did it wrong.
There you go.
Yeah, but you did it wrong, so that's why.
How do you have x squared?
Well, okay. X times x is x squared.
27 minus 1 and 1 is
Oh, Sean.
Equilibrium equation equals the KQ of.
Excellent. Now you're in the trouble.
If it's this good?
So you can't just minus an x squared.
Bro, I'm so
Yeah, you might be able to go the actual number, because now you have to solve for x. That's a minus sign, by the way, so you have to multiply it through and then amount of time, so just don't get lost in your own writing. Pull it through, see what you get.
Minus 14x.
Yeah? I
I think you would want to check because I didn't use a quadratic equation to solve.
You didn't? Excellent. I will, 1 second. You can start working on your Hebden.
Now it's extra. It's extra equation.
Oh, right, so
Your equilibrium values, one of them should come around to 0.3, and one of them should come out to about 0.1. You're getting roughly there, you're on the right track.
is it b squared or is it b? I think it's b
Well,
squared.
Yeah, why do you get 2 values?
Or my
Pardon?
Why do you get 2 values?
What's the question asking?
oh, and then you just divide by
Only CRBO2?
Yeah.
Oh, right, and in the pathway, one of their concentrations will come out to 0.3, and then one of their concentrations will come out to 0.1. One of those is the right answer.
Is it 0.3?
Now we can solve.
Because I only found 0.3.
Well, because
So you take that and there.
Why is it like looking to
you should see both of those numbers in the process of your calculation.
And
If you use both of those, it will be really obvious if you have the right answer. Mathematically, what are you doing? You did it right before. Okay, keep going. Did you cancel those two?
no, we already talked about those.
Yeah. Oh, now you're doing it both sides of it, right?
Wait, I'm going back to the
Yeah.
I'm confused because then
You took the square root of both sides. I would stop doing that because it's making it very hard to see your work. You've got roughly 0.1 in there. And then what's your
It's the
answer?
final expression.
That's
He wants to see our work.
right. And which answer is that for?
I want him
For
to.
the
Yeah.
COBR.
Does that not correspond with the answer?
I think we're supposed to square
Because you solved, you got 0.1 1 roughly. And then when you put that in, this is the one you're actually going for. You gotta put that in, multiply by 2.
I think so.
3 times 2 gives you 0.6.
Okay, my way would've worked.
You get enough.
Yeah, I feel like.
1, 2.
Three. Wait, can we give it a shot?
You've done all the math right. Yeah. Now head them. Yep.
Yeah, we also need all of
Ooh, here's a sort of look along.
That's what we are. How do you go
Cross multiply. Or just multiply both sides by minus 2x, like the algebra.
Wait, no, okay.
Well, look,
That's a good answer, mouse. It looks like a spider.
how did
It
you
looks
know
like a spider with
here
fingernails.
is there?
Did
Did you multiply both sides by 0.75?
Yeah.
You can't do that.
Why?
That's not algebra. If you multiply both sides by 0.75, that doesn't cancel. Because that is 0.75 minus 2x. So a minus or a plus, you can only cancel on the multiplication. So that you can multiply 0.75 by everything. Multiply by there and
We were flawed.
so the easiest way to do this,
Do you want to read my process?
you've done cross multiplication as a fast way to solve these.
Yes, 0.
No, I don't think it's extended. Like, I was shocked because I thought it was.
Okay, stop that. No blocking up. Stop using your fingers. So, let's go back. You've got this, you have the same thing. Oh, use actual numbers. But that might be true if you multiply it through. Is the square root of 7 2.645? So, all you do is multiply. And like if you have A over B equals C over D, right? Then you just cross multiply, and the answer is then AD equals AC. Yeah, and you can multiply divided. So if you multiply this through, that times that, then you have 2.645
Okay.
times 0.75 minus 2x. So you have to multiply that, and you'll have a minus, so it equals x. And then you'll have to like add that x to that side.
0.1315 is correct.
It's just regular.
Oh, let's go.
So you have the same approximation. Okay, well, you're extending to x.
I will know for sure once I see your x. But I think, no, the only thing I'm worried about is your minus signs are a lot like multiplication signs, and I keep thinking that you're gonna forget it. Oh, okay, fair.
I should have said restate.
Why do you have non?
We're just discussing something.
No, freaking way, chemistry. You're completely done.
Instead of reinstate.
That's what old exams, studying. Whatever you do,
looks really funky and not.
chemistry,
Yeah.
chemistry,
I should have said restate.
helping others. Oh, you could be helping. You could right there. I will go over it in the board. Oh, I already saw yours over there. Is your group, were you over there?
You can see my head there. Do you want to see my head there?
No quadratic formulas?
Why not? Yeah, well, that's crazy.
What are you doing with quadratic formulas?
Does
No, you
quadratic
didn't.
formulas also?
We did, you erased it.
But you went back and you
Cancel out
fixed
the
it.
square.
Okay, oh, you're doing it correctly now. And Felix,
Look how much I
working
have
on
left.
it.
Look how much I've done. It's not even.
You look like you're on the right track.
The book.
And, oh, yeah, x is equal to 3.145, you're on the right track. The most difficult thing about this problem is none of the chemistry. The most difficult part of this problem is that remembering your algebra from grade 10 and 11. So, they'll sharpen up very quickly. A reminder, you cannot cancel when you have when you have plus or minus. Subtraction and addition means that they are locked together. They have brackets around them to mimic where everybody is right now. You successfully, everybody in the class, extremely well done, recognized that this was 0.75 and divided by 2. Pretty much everybody, as I saw right away, knew that those were 0. This means we know it's going to shift that way.
Oh, Mr. Neufeld, balance it.
And balance.
Do you have 0.12 with the covert? Heather? Do you have 0.12 with the covert? Yeah, dog.
We don't need the other.
Yeah, dog. This math equation works. Yeah, dog. Sorry.
Wait, slow down.
That's the
Big math.
Now, your Hebden and old exams have a ton of ice table questions just like this. Get in there, do a number. Your algebra will speed up very, very quickly. But
Half of my calculus.
Yeah.
paying attention. Dylan, Luca. One of the things about this is
I didn't get the right answer.
Felix, is when you skip steps.
Mr. Neufeld, why is your
Hold it.
thing wrong?
Why is my
Your key two's wrong.
What the
Hober.
Inverse it.
All I remember from this class is Hober and Bober. You don't remember that?
Oh, that was that's the little way.
Yeah, that's when you were just spouting like randomness, talking about overate. I didn't
That was my
understand
favorite part of this class. Hober.
I think it's Randall. What do you think?
Okay, back to it. Number one, when you're doing these problems, I noticed a lot of, you wrote the equation and then a run to jump in, to put numbers in, calculate something on the side, and it was very, I would go back and say, like, put these things in, like, put them in, do x times x over 0.75 molar minus 2x, and because this helps you remember all the things. The most common error, I think, was just forgetting to square it. And you go, that's there. Then summarize it so that you can tell what the next step is. X times x is x squared over 0.75 molar minus 2x, also squared, and now we can put in the 7 because we know that it's equal to k cubed. You cannot cancel exponents when they're not identical. Show your steps. A lot I saw just immediately took the square root and went to the next step. But if you're not showing the mathematical calculation, it's very easy for you to skip doing it to the other side. So a lot of people automatically did it to that side, but if you went like that, you'd probably remember, oh right, I gotta do it to both sides. And show that. Lets me know what you're doing, lets anybody who's overlooking your work know what you're doing. It makes it very clear, because the algebra is not difficult. The difficult part is just making sure that you're not skipping anything. And if you're very clear in method, and you show a method, you're probably less likely to skip it as well. This becomes then easy. It becomes x over 0.75 molar minus 2x. And a lot of you don't understand what sig figs are because you keep writing this. That's not a real number.
Yeah, it is.
Math says it is. We all know that math are liars, which is why I've got a brand new sign to put up all of that math stuff that a math teacher put up. The library let me take this, and that's going right up there. Fiction.
Oh my god.
Math is just made up. Root 7 is of no value in chemistry. You need an actual number. Sig figs give mathematicians the heebie-jeebies for a good reason, is because you're introducing a dose of reality into their mythological carefree lives.
But don't scientists have different sig figs depending on like what subject they do for like constants? Like,
Oh, the method we show you to calculate sig figs is an extreme simplification. So if once you get up there, it kind of sometimes like use calculus to figure out what your sig figs are.
What the heck?
Because you have to see what the numbers are doing and where the error actually is. You may have to take a derivative here and there, and then you calculate it. So when we do it, those are rough estimates, and it works decently enough as a rough estimate. But you do other things, like we taught you how to round. If the number before is 5 or above, you round up. But for engineers, who if they build it wrong, buildings and bridges literally fall down, they check the 5 and then they check the number past it. If it's even, I think they round up, and if it's odd, they round down. Because 5 isn't bigger. 5 is dead in the middle. So if you're always rounding up at 5, you are introducing a consistent error into your calculations. And that's not a random error, so it's not going to wash out. So they will actually round up sometimes and down sometimes if it's 5.
But if it's 5, wait.
Just don't round.
If
So
it's right
you
in the
have
middle, should they just leave it at
9.854, and you have to round that number, then because it's 4, they'll round it up. If this turned out to be 3, they would round it and down, keep it at 8.
It doesn't seem like it would make sense.
Because this number is random, so that means that roughly half the time they're doing one thing and half the time they're doing the other thing. It's just to make it based random.
Why do you want it like random?
It's
You don't want a consistent error. If a consistent error means that you're always adding a little bit, then by the end, you will have always added a little bit and it will be off. But if you add sometimes and subtract sometimes and it's random, they will even out.
It's consistently
If it's
inconsistent.
random,
Yeah.
like it's not.
Then there could be
consistent.
trends where it's consistently
When you're at that level, that has been shown to work. But there's other ways. Anyway, off to this. Now that you have an actual number, you can just multiply it through. Now you could crisscross, which is what I used to do in school because I found that way easier. I'd make that 1 and I'd multiply through like that. Or you can multiply multiply both sides by 0.745 molar minus 2x, which will give you the same thing. So you multiply both sides by the denominator, again, algebra. And then either way you do this, you will end up with x equals 2.65 molar 0.75. Normally I would just multiply that through right away, but I want to be very clear about the algebra. And then you just multiply it through. What is 2.65 times 0.75? Someone who did it. 3 point something? No, it's less.
It's less.
Less than
It's
that.
1.9875.
1.9875 molar minus 2 times
5.3.
5.3x. We then add 5.3x to both sides. Then you have 6.3x is equal to 1.9875 molar. I think I've dropped some sig figs here and there, but
You did.
finally, we should get x is equal to 3.3?
6.3. It should be 0.315.
0.315, and it'll end up being lower. We're not done, because what we actually asked for was this number. We want the concentration of COBr2. Concentration of COBr2 is equal to 0.75 minus 2x, 0.75 minus 2 times 0.315 molar equals 0.12. Something like that? The 2 sig figs?
Yeah.
Because 0.315 comes out to about 0.6, minus 0.7 minus 0.6 comes out to about 0.1. And so, but all of that part is just algebra. Remembering when to cancel, when not to cancel, when to take the square root.
And then
You will never have to solve for a quadratic. So if you get to this point, and here's the point where I would expect you to remember, is that if you've gotten to here, and this is the part that makes Chemistry 12 easier than Chemistry 12 AP, if you remember, is that if you've done this, so that you can't take the square root of both sides to make it easier, then go back and re-examine your equation. Did you balance it properly? Because you will always, either, if you have a squared, you'll always be able to take the square root and get it out, or in a few rare cases, minus it out because there's one on both sides in some weird kind of way. But you're always able to do this. You will never have to solve for a quadratic. If you ever do Yes, it is technically correct. You have to know which answer to pick. I think you've done enough math now, you probably know. You can't have negative amounts of stuff, so you eliminate anything that's negative. And so you have to pick the one that's positive. But the number of times to someone who's gone, I'm not gonna do that. I know how to solve a quadratic. And then they just write stuff down and it never seems to turn out quite right. They either pick the wrong one or they calculate it slightly wrong. It's so much easier to do this. And this is just the guarantee in Chemistry 12. I'm not going to expect you to solve the quadratic in a test. I don't think your Hebden does either. So there always should be
Mr.
something.
Ninfa,
Yes.
did we ever fully finish the PLOE booklet?
Yeah.
I don't think so.
We did all those in the board.
Oh, right.
Yeah. And then when you're studying, you can now use all those graphs and read the questions. So for the rest of it, how much? We go to 12? 11:45. So we got about 15 minutes, a little less. You can start getting out your Hebden, studying, old exams if you've done those, helping others if you've completely done and extremely confident. Sophia has volunteered to tutor anybody in the entire class that needs help.
Sick.
You said you were completely done?
Sophia.
Yeah, well done. Excellent. Good job.
I'm done as
What?
well.
I'm gonna minus a mark every time you ask me.
Bro, you're dumb.
2.
Is it like December 4th?
They give you out a lot
I
of
told you last day, it's on the Google Classroom, you have 3 different
I'm
ways
just
of
double
looking at it.
It's December 15th.
December 8th.
December 8th.
December 8th.
It's December 25th.
Sophia.
When we're
You're
not-
kidding about taking that
It's our
mark.
Christmas
What?
Day. December 25th. It's our Christmas
Felix,
Day.
do you think-
So many different things I could do. Secretly, behind the scenes.
Oh wait,
This is so.
Also, they don't, all those quizzes go into our term 1 marks.
Oh, weren't you here last, did I not announce it? The last quiz you wrote,
Okay.
the very last one,
I'll just go.
did not go into your term 1 marks. If you did really well and you're like, it must go in, email me and I'll put
Oh, wait,
it
you
in.
didn't put it
But I
in.
just didn't have time to do the whole class and I'm not gonna update it now with the
Oh,
whole
oh.
class.
You didn't put
So-
what in?
Pardon?
You didn't put what in?
The last quiz. So it's just sitting in
Thank
6th
you.
grade, I haven't put it in the mark
Thank
book
you.
yet.
Felix,
Um,
you
We
were
love
wrong.
you.
There's a few people where it might improve your marks, and if that is you, tell me, I'll put it in.
Thank you.
Your mark 1, your term 1. I have until the 4th to change marks.
How do I know?
You can head out, yes. You stayed for longer than I was expecting. Well done, Annette.
That's crazy. Teachers have a power.
That was grit.
Mr. Newfeld, why did you ever return our lab that we
No, no, I haven't.
Did you why?
At the beginning of the year, I made a solemn promise that you would have all tests and quizzes the very next day that you have class, and then mark all your labs single week. I've clearly broken one of those promises.
I'm okay with that though.
And in fact, to maintain the other promise,
That's fair.
that's part of what's doing that.
Okay.
And once reports came up, I've written the equivalent of a 38-page essay.
What?
That's how much all your reports are together.
Wait, did you have to
38
write
pages.
them
So
by
you're
hand?
not gonna ever
No, I
return our
typed
labs?
Oh, I will. I'm gonna start
I'm
back.
ChatGPT.
For every class that you teach, like every student, because you teach multiple different.
Yeah, so I have to write a report for every student.
I feel like I'd
But
rather
they're
like
like this now.
I'd actually lose my mind.
Pardon?
They're like this now. Like,
Yeah.
That must be
they're
so
looking for
tedious
that
because
long.
you're almost writing the same numbers.
Yeah.
I think some teachers copy and paste like a general message.
I-
and then
That's what
change
Mr.
it a
I
little.
used to do that a little bit more. This time they're all subtly, we're also not allowed, there was a lot more rules this time, so I used to put in like little things like, oh, I like so-and-so's little giggle in class, and they get a problem right. And we're not allowed to write that anymore.
What?
Yeah, so the Mr. Cullis amazing reports have gone away. And your report will seem
Really bored.
very bland.
Wait, so
Why
why
are they doing that?
I just found out, some of you have said in your self-reflections, like, I have a goal of 88% in this class, and I might have written that. Apparently for the next reports, I'm not allowed, I have to say,
Why though?
proficient high or extended.
Oh my.
So just so you know, hammer's coming down, so they might even change further.
Why? Okay, wait, why can't you be like? Why can't you say, oh?
These people need to
Um,
take that serious.
The reports are intended to be vaguely encouraging. Let your parents know how you're doing in class and what your goals are.
Why can't they be like
And,
a lot encouraging?
And we never want to put in something in there that would be really individualized, that isn't about your learning.
Ooh.
Why are they being so annoying about it? So unfair.
There is a, I don't wanna, cause obviously I may have a certain point of view on it, but that's not fair. Cause I'm also biasing you, and I have said before, you shouldn't believe anything I say.
Yeah.
Okay, but what do you say?
Maybe we should turn the
What
lights
should I
off.
say? Well, not, right, so these reports were designed, to be extremely effective